Hello everyone. Today's video lecture is based on topic electricity. There are the two forms of electricity. First is the static electricity and second is the produced electricity. Static electricity is an electrical charge at rest and produced electricity is produced by either magnetism, chemicals, light, heat or pressure. Produced electricity. Electricity is nothing but the secondary form of the energy because it is produced by using the another sources like magnetism or chemical source or by using light or by using the heat. Okay, so electric generators are one of the examples of the produced electricity by magnetism. Then second is the battery or fuel cell is one of the example of the produced electricity by using the chemical reactions. Third is the photo cell is one of the produced electricity by using the light. Thermocouple or nuclear power is the example of produced electricity by using the source heat. Next is the crystals is one of the example of produced electricity by using the pressure. Next is the alternating current. What is mean by the alternating current? There are the two types of the current. First is the AC. First form of current is AC and second is the DC. AC is known as the alternating current and DC is known as the direct current. If the high and low voltage terminals switch locations periodically, the current will flow back and forth in the circuit. This is called the alternating current. Alternating current is nothing but the bidirectional current. AC means क्या होता है? AC जो करंट है वो बायडायरेक्शनल है, मीन्स दैट फ्लोज इन बोथ डायरेक्शन. वो आपको पॉजिटिव साइकिल भी देगा एंड नेगेटिव साइकिल भी. AC करंट जो है वो बोथ डायरेक्शन में फ्लो होता है. इट गिव्स द पॉजिटिव एज वेल एज द नेगेटिव साइकिल. हियर वी कैन सी, यहाँ आप देख सकते हैं, दिस कंसिस्ट ऑफ द पॉजिटिव साइकिल एंड हियर इज द नेगेटिव साइकिल. This is the positive cycle and this is the negative cycle. This is nothing but the AC. Okay. This X terminal is denotes the time and this Y on the Y terminal you can see the positive and negative terminals are here. Alternating current is nothing but the bidirectional current. ये दोनों डायरेक्शन में फ्लो हो रहा है तो इसे हम bidirectional current कहेंगे. That is the AC current. Next is the DC current and DC is the unidirectional current which flows only in the single direction. In DC में आपको या तो आपको पॉजिटिव साइकिल मिलेंगी या तो नेगेटिव साइकिल. Alternating current, it is the form that comes in our house, means it is a magnitude of 220 volt and a frequency of 50 hertz. जो हमारे हाउस में मेंस से जो करंट आता है उसे कहते हैं अल्टरनेटिंग करंट, और जो मेंस से आपको वोल्टेज मिलता है दैट इज़ अ 220 वोल्ट्स, इसे कहते हैं एसी वोल्टेज. दिस इज़ द एसी, दैट इज़ द अल्टरनेटिंग. और जो हमें फ्रीक्वेंसी मिलती है, फ्रीक्वेंसी इज़ द 50 हर्ट्स. ओके. नेक्स्ट इज़ द डीसी करंट. If the voltage is maintained between 2 points in the circuit, charge will flow in one direction from high to low potential. This is called direct current. अब direct current क्या है? In direct current we can see only the positive और negative cycle. Direct current में आपको या तो positive cycle मिलेगा या negative. Here we can see this voltage is along the positive. Here you get only the positive cycle like this, only the positive cycle. Here negative cycle is absent. और you will get only the negative cycle like this. That is a negative. This is known as the direct current, and this is the unidirectional current because it's flowing only in the single direction. यहाँ आपको पॉजिटिव साइकिल मिलेगा, यहाँ आपको नेगेटिव साइकिल मिलेगा. So this is the unidirectional. This flows only in the single direction. Next, AC versus DC. Okay, most of the home appliances runs on the DC. जो हमारे घर में अप्लाइंसेस होते हैं वो वर्क करते हैं ऑन द डीसी करंट. ओके, बट मेन से जो आपको मिलता है डेट इज़ द एसी करंट. सो वी हैव टू कन्वर्ट दिस एसी टू द डीसी. आपको एसी का कन्वर्जन डीसी में करना होता है. दैट इज़ बाय यूजिंग द पावर सप्लाई. दैट विल बी स्टडी इन द नेक्स्ट स्लाइड. ईच होम अप्लायंस इज इक्विप्ड विथ इट्स ओन पावर सप्लाई. सभी जो भी आपके घर में अप्लायंसेस है दे हैव इट्स ओन पावर सप्लाई. उनमें अपना पावर सप्लाई होता है विच कन्वर्ट्स एसी टू द डीसी, जो एसी का कन्वर्जन डीसी में करेगा. Why we are supplied AC when most of the appliances run on DC? Okay, because we know that here the every home appliances have its own power supply. So we can supply AC, then that power supply will convert this AC to the DC. Then our appliances will work properly. Next is symbols of power sources. Here we can see DC voltage source. What is the symbol of DC voltage source? Is this, contains negative positive. What is the symbol of DC current source? Is this, denotes the arrow. What is the symbol of AC voltage? Is this. And what is the symbol of AC current? Is this. Always AC is denoted by this cycle because AC contains positive and negative cycle. So here in both this symbols we can see both the AC symbols for the voltage and current. It contains this cycle, AC cycle. AC is always denoted by this AC cycle. Next is power supply. Power supply is a device that supplies electric power to an electrical load. Okay, this, what is the use of this power supply? Power supply converts AC to the DC. That is the use of the power supply. Power supply converts AC current or AC voltage to the DC current or DC voltage. This power supply contains the transformer. What is the use of transformer? Transformer is a device that converts high AC to low AC or high DC to low DC. That is the use of the transformer. Transformer also have the two types, step up and step down. In step up, the transformer converts, step up means converts low to high, and step down that converts high to low. In power supply after the transformer, the rectifier is used. What is the use of rectifier? Rectifier is used to convert AC to DC. The transformer is converting only high to low AC or high to low DC, but this rectifier converts AC to DC. After this rectifier, some filters are used to get the pure DC current or DC voltage. This is the use of the power supply. Next is some measuring instruments. Here we are going to discuss some measuring instruments which are used in the physics laboratory. A measuring instrument is a device for measuring physical quantity. When you have to measure some physical quantities, at that time you can use the measuring instruments. The instruments for measuring electrical quantities are as follows. First is a voltmeter. अगर आपको voltage measure करना है तो आप यूज़ करोगे वोल्ट मीटर. सेकेंड इज़ द एम मीटर. अगर आपको करंट मेज़र करना है तो आप यूज़ करोगे एम मीटर. थर्ड इज़ द ओहम मीटर. जब आपको रेजिस्टेंस मेज़र करना है तो आप यूज़ करोगे ओहम मीटर. देन फोर्थ इज़ द मल्टीमीटर फॉर मेजरिंग ऑल थ्री क्वांटिटीज़. दिस ऑल थ्री अबो क्वांटिटीज़ वी कैन मेजर बाय यूजिंग द मल्टीमीटर. दैट इज़ द वोल्टेज, करंट एंड रेजिस्टेंस. Okay, so why it is called as a voltmeter? Because we are going to measure the voltage, and unit of voltage is volt, so it is a voltmeter. When we have to measure the current, then unit of current is ampere, so it is the ammeter. when you have to measure the resistance, unit of resistance is ohm, so the meter is ohm meter. Okay, and this is a multimeter because we can measure the multiple quantities like voltage, ammeter and voltage, current and resistance. So it is a multimeter which can measure all the three quantities. First is a voltmeter. Here in this image we can see both the voltmeters are present, AC and DC. How can we identify the AC and DC? वोल्टमीटर्स हम आइडेंटिफाई कैसे करेंगे, AC है या DC है. ओके, हियर वी कैन सी दिस. यहाँ पे आपको दिया है अंडर द वोल्टेज देयर इज़ अ सिंगल लाइन, सो इट डिनोट्स द DC. ओके, और अगर आपको AC साइकिल दी हुई है तो दैट इज़ द AC. लाइक इन दिस second image we can see there is a under the voltage there is a AC cycle, so this is the AC voltmeter used to measure the AC voltage, and this is the first is the DC voltmeter used to measure the DC voltage. Okay, these voltmeters are available in several ranges. Here we can see in first image the range of this voltmeter is starting from 0 to 15. In second image we can see the range of the voltage is starting from 0 to 150. ओके, वोल्टमीटर जो है वो डिफरेंट रेंजेस में अवेलेबल होते हैं, फ्रॉम 0 to 10, 0 to 50, 0 to 100, 0 to 150, which you have applicable, you can use that corresponding voltmeters. Next, voltmeter have high impedance and hence are connected in parallel across the points between which potential difference is to be measured. Okay, voltmeters have a high impedance, so they are always connected in parallel. Why that voltmeters are always connected in parallel and ammeter are always connected in the series? There is some basic reasons behind that why we have to connect this voltmeter in parallel only, not in the series. An ammeter is always connected in series, not in the parallel. That can be discussed in the next slides. Here we can see the ammeter. Ammeter also has the two types, that is the AC ammeter and DC ammeter. Here also first image shows the ammeter which is AC, because under the A there is a AC cycle is shown, so this is the AC ammeter. In next we can see under the A there is a one single line, so this is the DC ammeter. These are the two types of the ammeter. When we have to measure the AC quantities, at that time we use the AC ammeter, and when we have to measure the DC current, then at that time we use the DC ammeter. These ammeters are also available in several ranges. Here in first we can see the range of ammeter is 0 to 5. In second, range of ammeter is 0 to 3. Like this, there is several ranges are available, like 0 to 10, 0 to 50, 0 to 100, up to 500,000. The several ammeters are available. Ammeters, on other hand, exhibit a very small resistance and hence are connected in series. Ammeters are always connected in series to the circuit. Why? Because in order for voltmeter to measure a device's voltage, it must be connected in parallel to that device. This is necessary because objects in parallel experience the same potential difference. Okay, because voltmeter has the very high resistance that its connection do not alter flow of current in the circuit. Now if it is connected in series, then there will be no current. Okay, if instead of ammeter we will connect the voltmeter, so there will be no current. Okay, hence it is connected in parallel to the load across potential difference to be measured. and these emitters are always connected in series, not in parallel. If we connect this emitter in parallel, there will be high flow of current through the emitter and it would cause the short circuit. Okay, if we connect this emitter in parallel, so it will cause the short circuit and results in damaging the emitter and also the circuit. Now this is the ohm meter. Ohm is the unit of the resistance, so while measuring the resistance we can use the ohm meters. Ohm meters are not the AC or DC. Okay, this is single, that is ohms. Here in this device we can see the range is starting from 0 to the 100 ohms. So these are the two terminals, positive and negative. Positive is black denotes the negative and red denotes the positive. This is the symbol of ohm meter which measures in ohm. Okay, here red denotes the positive and this black arrow denotes the negative terminal. A red arrow denotes the positive terminal. Next is the multimeter. Multimeters are of the two types, analog and digital. What is the difference between analog and digital? Analog. In analog, we have to take the readings by using that needle. Here in first image, you can see there is a needle and readings are given here like this. These are the readings. Like on the scale, the readings are given like this. Means manually we have to calculate here. But in digital multimeter, you directly get the readings. Means directly the number shown on the screen. Okay, these are the two types of the multimeters, analog and digital. But nowadays digital multimeters are mostly used. Here this is the diagram or the arrows which showing the parts of the multimeter, digital multimeter. Digital multimeter has three parts. First is the display. This is the display. Second is the selection knob. Here is some knob for selecting and some ports here. Positive, negative ports are given here. Okay. This digital multimeter are used for measuring all the quantities like current, voltage, then connectivity, resistance also we can measure by using this digital multimeter. Digital multimeter, two probes are plugged into two of the ports on the front of the unit. COM stands for the common and is almost always connected to the ground or negative of the circuit. The common probe is conventionally black, but there is no difference between the red probe and black probe other than the color. Okay, this is only to identify that this black and red color is only given to identify that positive and negative terminal. Otherwise there is no difference between that the terminals. Common or negative denotes the ground terminal and positive is used for connecting the positive terminals. Next is measuring voltage using digital multimeter. If you have to measure the voltage by using digital multimeter, so it can be measured by some experiment. Like we can take one cell. Here in this image you can see a one battery or cell we are using here. Plug the black probe, that is common, and red probe into the milliampere volt ohm. Here you can see this positive is or negative is connected to the common and positive is connected to milliampere volt ohm terminal. Okay, both have like this black wire should be connected to the negative terminal of cell and this red wire is connected to the positive terminal of cell. Okay, knob of this positive is connected to positive terminal of cell and knob of negative is connected to the negative terminal of cell. And here this knob is fixed at 2 volts. Why it is 2 volts? Because this cell is of range 2 volts. Okay, so that knob is adjusted on the 2 volts. Okay, after fixing this positive and negative knob on the cell, we can see here on the screen the reading is 1.54. Okay, but the value of that cell is 2 volts, and here it's showing the 1.54 volts, means this cell is discharged by amount 46. Okay, now current reading is 1.54 volt. So by this way we can calculate the voltage of the given cell by using the digital multimeter. Okay, to start, let's measure voltage of battery. Plug the black probe into common, okay, like this, then red probe to the milliampere volt ohm. Set the multimeter to 2 volts in the DC range. Here we can see this is the DC voltage and AC voltage is here. Connect the black probe to the battery's ground negative and red probe to the power positive. By this process we can measure the voltage of cell or battery. Next, we can measure the next quantity. Measuring resistance using digital multimeter. How can we measure the resistance? Okay, here in this image we can see one resistance is used. This is the resistance. Okay, so same we have to connect this negative to the black to the common and positive to the milliampere volt ohm. Okay, because we have to measure the resistance which is in the ohms. So same negative is connected to the negative of resistance and this positive is connected to the positive of resistance, by which we get this value. Okay, pick out the random resistor and set the multimeter to the 20 kilo ohm setting. Here it is set on the 20 kilo ohm like this. By this process we can measure the resistance of the resistor which is in the ohms or kilo ohms. Next is measuring current using digital multimeter. The reading of current is one of the tricky process in the world of electronics. It's tricky because you have to measure current in series. Here we have to measure the current in series. So this is the tricky process. This is same as we measured before this. Black is connected to common terminal and negative is connected to the milliampere volt ohm terminal. By this, in this image you can see how the current is measured. Okay. Next is continuity testing using digital multimeter. Digital multimeter is used for testing the continuity between the two connections. Continuity testing is the act of testing the resistance between 2 points. If there is very low resistance, the 2 points are connected electrically and tone is emitted. If there is more than few ohms of resistance, then circuit is open and no tone is emitted. This test helps to ensure that connections are made correctly between 2 points. This test also helps us detect if 2 points are connected that should not be. Here we can see, for testing the connectivity we have to set the knob on this diode symbol. Okay, we have to set the knob on this diode symbol by which we can test the connectivity between the 2 points in breadboard or in any electronic circuit. Set the multimeter to continuity. Okay, like on this diode mode. It may vary among digital multimeters, but look for a diode symbol with propagation wave around it, like sound coming from speaker. When the connectivity is right, then at that time sound comes from that speaker and we can identify our connections are proper. Okay, that's all about the measuring instrument. This all digital multimeter, ohm meter, then ammeter, then voltmeter, these all are the measuring instrument. That's all. Thank you so much.